Alright guys, so sa pagpapatuloy ng ating lecture about fluid mechanics, we are going to start solving problems for the fundamentals of fluid flows. So now we are going to answer these three questions. So this is the first part ng ating mga solved problems for fundamentals of fluid flow. So sa mga succeeding videos natin, magsosolve pa tayo ng iba pang problems. But for now, we have three questions here na sasagutan natin. No? So, unahin natin itong problem number 1. So, by the way guys, as I said earlier, continuation lang to ng ating lecture. No? So, we are not going to discuss yung mga equations natin. We are just going to use it or apply it now. So, kung meron kayong mga questions about the equation, you can go back sa ating previous videos. No? Now, problem number 1, what is the rate of flow of water passing through a pipe with a diameter of 20 mm and speed of 0.5 meter per second? Okay, so sulat muna natin yung ating mga given. No? So, this is our pipe and our pipe has a diameter of 20 millimeter. Okay, and then water is passing through this pipe with a speed of 0.5 meter per second. Okay, so yan ang speed ng water natin na pumapasok dito sa ating pipe. So our requirement is to find the rate of flow ng ating water. Okay, so our requirement is the rate of flow of our water. Okay? And this is, as we know, we noted as Q sa ating previous lesson. Okay? So, flow rate Q. So, we have flow rate Q is equal to the area multiplied to our velocity. So, therefore, our Q is equal to the cross-sectional area of our pipe, which is equal to pi over 4 kd squared. And we are going to multiply that dito sa ating velocity. Okay, so using this equation, our Q is equal to pi over 4 times our diameter of the pipe, which is 20 millimeter. We're going to convert that to meter. So, 1,000 millimeter to 1 meter. We're going to square that and multiply to our velocity, which is 0.5 meter per second. Okay? So, as you can see dito sa ating mga units, our millimeter will be cancelled out. And our meter here will be squared. So, if you multiply this to another meter here, it will be a cubic meter, no? So, it will be a volume. So, our final dimension here or unit will be in cubic meter per second. So, let us calculate our Q. So, our Q will be equal to, we have pi, okay, so we're going to get the value of pi divided by 4, okay, multiplied to 20 divided by 1,000, and we're going to square that. This is equal to, then multiplied 2.5. So, we have here our Q, which is equal to 1.57 times 10 to the negative 4 cubic meter per second. Okay, so this is our final answer for this question. Okay, so now we're going to proceed sa ating second problem. So, here we have water flows through a 75 millimeter diameter pipe at a velocity of 3 meters per second. So, halos katulad nung first problem natin, no? Given ang diameter ng ating pipe and the velocity. But this time, we're going to look for first yung ating volume flow rate in meter cube per second and liter per second. And then, we're going to get the mass flow rate in kilogram per seconds. And then, we're going to get the weight flow rate in Newton per second. Okay? So, we're going to write first our given here. This is our pipe with a diameter of 75 millimeter. And our water is flowing in our pipe with a velocity of 3 meter per second. So first, let us solve for our volumetric flow rate in cubic meter per second. Then we will convert it to liters per second. So our Q is equal to cross-sectional area multiplied to the velocity. Okay? So our Q is equal to pi over 4 multiplied to the diameter of our pipe here, which is 75 millimeters. So, now we are going to convert it directly to meters para hindi na tayo mahirapan sa conversion natin. No? So, 75 millimeter is equal to 0.075 meters. Okay? Then we're going to square that and we will multiply that to our velocity here, which is 3 meters per second. Okay, so our answer will be in cubic meters per second. So our Q is equal to, so we will solve this again. So we have pi divided by 4 multiplied to 0.075 squared, then multiplied to 3. Okay, so our volumetric flow rate in cubic meter per second is equal to 0.013. Okay, so we have 0.013 cubic meter per second. Okay, so now we got our answer here for the volumetric flow rate. However, we're going to convert that also to liters per second dahil inahanap din yan dito. Okay, so our Q, which is 0.013 meters per second. Okay, we're going to multiply this to our conversion factor, which is 1000 liters per cubic meter. So I'm sorry, this is in cubic meters. So our cubic meter sign here will be cancelled out. Okay, so we are going to multiply our answer by 1000. So our answer will be 13.25 liters per second. Okay, so we have our Q, which is equal to 13.25 liters per second. So we got our second answer here. Okay, so now let's go to requirement B, which is the mass flow rate in kilograms per second. Okay, so we already know our formula here based from our previous lecture, no? So our mass flow rate is equal to the density of our material multiplied to the volumetric flow rate. So we're going to do that now here. So our M is equal to the density of water, which is 1000 kilograms per cubic meter. And we're going to multiply that sa ating volumetric flow rate, which is 0.013 cubic meters per second. Okay, so our cubic meters will be cancelled out. Therefore, our answer will be in kilogram per second. So our M will be equal to 13 kilogram per second. Okay, so this is our mass flow rate, no? So we have our answer now here. This is the mass flow rate. Okay, so now we are going to answer letter C. Okay, so ano nga ba yung requirement natin sa letter C? We need to get the weight flow rate in Newton per second. So we're going to get that, okay, our weight flow rate by multiplying our Q, our volumetric flow rate, with our specific weight, okay, or the unit weight. Okay, so our W is equal to our Q, which is 0.013 cubic meter per seconds. Then we're going to multiply that to our specific weight. Well, our specific weight is equal to the acceleration due to gravity multiplied to the density of our material. Okay, so in this case we have water. So we're going to multiply this to the acceleration due to gravity, which is 9.81 meters per second squared. Then the density of water, which is 1000 kilogram per cubic meter. Okay, well, as you can see, we have units here which is kilogram meter per second squared, which is equal to 1 Newton. 1 Newton is equal to 1 kilogram meter per second squared. Okay, so as you can see in here, our meter per second squared and kilogram will be cancelled out. Our cubic meter will be cancelled out, so our unit will be in Newton per second. Okay, so now we're going to calculate for our weight flow rate, in which okay, so we're going to check 0.013 times 9.81 times 1000 is equal to 127 Newton per second. Okay, so that will be our answer, 127.53 Newton per second. Okay, so this is our final answer dito sa ating letter C. Okay, so now we're going to proceed sa last problem natin. So we have air at 30 degrees Celsius. Okay, so we have degree here. Okay, so we have air at 30 degrees Celsius and 110 kilopascal flows at 20 newtons per second through a rectangular duct that measures 160 millimeter by 320 millimeter. Compute the average velocity and volume flux, and we will use a gas constant of R is equal to 29.3. So we have a gas constant na given, so therefore we can assume that we have here an ideal gas. Okay, so sulat muna natin ang ating given. So we have our rectangular duct which is measuring 160 millimeter by 320 millimeter. Okay, and then air is flowing through this rectangular duct. Okay, and the condition of our air is that we have temperature at 30 degrees Celsius, we have pressure at 110 kilopascal, and then it flows through our weight flow rate, which is in 20 Newton per seconds. Okay, so now we need to get the velocity. Okay, kailangan nating makuha yung velocity and the volume flux, which is our Q. Okay, now we learned from our lecture that W, and we have used this already dito sa ating problem number 2, no? Our W is equal to the specific weight multiplied to the volumetric flow rate. And our volumetric flow rate is equal to area times the velocity. Therefore, this is equal to the specific weight multiplied to the area times the velocity. Okay, so since we know that we have an ideal gas here, therefore we can use the ideal gas equation PB and RT. No? So we're going to use that. Okay, so using that, we will get our specific weight, which is equal to the pressure over our gas constant R and our temperature. Okay, so therefore, our specific weight is equal to our pressure, which is 110 kilopascal. Okay, so we are going to convert this to Pascal, no? Dahil lang kailangan nating makuha na specific weight will be in Newton. Okay, so we're going to convert this to Pascal. So we have 1 kilopascal and 1000 Pascal. Okay, and then we know that 1 Pascal is equal to 1 Newton per square meter. Okay, so now we have our expression now here in Newton per meter squared. Now, dito sa ating denominator, we have our gas constant, which is in 29.3 meters per Kelvin. And we will multiply that to temperature, which is 30 degrees Celsius. Okay, and we're going to convert that to Kelvin, so we will add 273. So this is now in Kelvin. Okay. Okay, so now let us check our units. Our temperature in degrees Celsius is converted to Kelvin, but our Kelvin will be cancelled out. Our Pascal will be cancelled out. Our kilopascal will be cancelled out. And then, ang matitira sa atin is Newton per cubic meters, no? So that will be our unit here. So now let us solve for our specific weight. Okay, so our specific weight will be equal to, okay, so let's bring our calculator here, 110 times 1000. Okay, then we will divide this to 29.3. And then we're going to divide this dito sa ating temperature, which is 30 plus 273. Okay, so our specific weight will be 12.39 Newton per cubic meters. Okay, so meron na tayong value ng specific weight. Okay, since given ang dimension ng ating rectangular duct, therefore we can get the cross-sectional area. Okay, so our cross-sectional area will be equal to 160 millimeter multiplied to 320 millimeter. So we will have millimeter squared here, but we need to convert this to square meter. So we have 1000 millimeter in 1 meter, and we're going to square that. So in here, our unit will be square millimeter, and in here we have square meter by square millimeter. So our square millimeter will be cancelled out. Kaya ang maiwan sa atin dito is itong square meters. So therefore, our area is equal to 160 times 320, okay, divided by 1000 squared. So therefore, our area is equal to 0.0512 square meter. Okay, so kailangan natin makuha is itong velocity. Okay, but we already know our W, our weight flow rate, which is 20 Newton per second. And we already know the specific weight, and we know the area. So we can get our V, no? So we have W is equal to our specific weight times area times the velocity. So our W is equal to 20 Newton per second. And this is equal to our specific weight, which is 12.39 Newton per cubic meters, times our area, which is 0.0512 square meter, times our velocity. Okay, so therefore our velocity is equal to 20 Newton per second over 12.39 Newton per cubic meter, okay, over 0.0512 square meter. Okay, so let us check our units, no? So we have the velocity, we'll have here Newton will be cancelled out. Okay, so we have this one cancelled out. Then we have square meter here and cubic meter here. Therefore, may maiiwan pa tayo ditong meters, no? So therefore, our unit will be in meter per second. Okay, so now let us solve for that. We have 20 divided by 12.39. And again, we're going to divide that to 0.0512. So we have 31.53 meters per second. So this is our average velocity, no? So we have our answer right here. Okay, so this is our average velocity. Okay, now we need to get the volume flux, which is our Q. And we know that Q is equal to area times the velocity. So our Q is equal to our area, which is 0.0512, okay, square meters, multiplied to our velocity, which is 31.53 meters per second. So therefore, our unit will be in cubic meter per second. So our Q is equal to 31.53 times 0.0512, which is equal to 1.614 cubic meters per second. So this is our final answer here.